Okay, I like this quote. "One day, sir, you may tax it." And that's something that Michael Faraday said to Mr. Gladstone when he was asked about the potential worth of electricity. So, all scientific discoveries start out as just like, oh, wow, that's cool. And some of them never have a practical application. But some of them change the world. And so we should be funding basic science research just for the sake of finding stuff out, because it leads to things like electricity. Lightning. Interesting. Today, which is rather unusual around here, it's raining outside, and I actually saw lightning on the way in. I didn't hear any thunder, but yeah, usually there's thunder as well. Sometimes we have dry lightning without the rain, but today it's wet. So lightning is just a very dramatic expression or demonstration of how powerful electricity is. And a battery is going to work on similar principles. And if you've ever been shocked by an electrical outlet, there's a lot of power in there, and electricity can do a lot of damage. But the driving force for both lightning and batteries is the same. Electrons flow away from a negative charge towards a positive charge. So that's a basic thing we learned in Chem 1A. Opposite charges repel each other. Opposite charges attract and like charges repel. I'm not going to test you on lightning, but just let's talk a little bit about what it is. So in a thundercloud, you've got these violent air currents tossing water droplets around. And there's ice particles up there too. That's why the clouds are white. And so all of this is tossing around, and it causes electrons to get knocked off of molecules. So they bang together, electron gets knocked off. Now we have positive charges and negative charges. The positive charges accumulate on the ice crystals. The ice crystals move towards the top of the cloud, and the negative charges remain on the wet, slushy bottom of the cloud, and so you have a separation of charge. And that separation will exist until a channel of ionized air develops between them, which allows massive amounts of electricity, of electrons, to flow through it, and that's lightning. So sometimes we see lightning just up in the sky, and other times the lightning actually strikes the earth. So if a cloud gets close enough to the ground, the negative charges at the bottom of the cloud cause the ground to develop a positive charge, and then the channel of ionized air forms between a cloud and the ground, and the charge flows to the earth, which is cloud to ground lightning. And if you've ever been anywhere close to a cloud to ground lightning strike, it's very violent, right? It makes a lot of noise as well. So, any questions about lightning? So, batteries. How do batteries work? In a battery, you have two different substances that have different affinities for electrons. One of the substances really wants those electrons more than the other substance. And if we separate those charges, one will develop a positive charge, the other develops a negative charge, and we'll have that charge separation until something connects them and allows charge to flow between them, a conductive path. And so when that happens, the electrons will flow from the negative thing to the positive thing. So batteries have a positive terminal and a negative terminal, right? And they're just going to sit there until you connect the terminals. It's not a good idea to connect them with just like a wire. Usually we connect them with a device, right, to make use of the electricity as it goes through. So usually we're going to use a metal wire with some sort of an electrical load, your phone or something, and that allows the electrons to do work as they move towards the positive end of the battery. Any questions?